So Jesse, to properly size a ductless system for my home, what factors will you consider during the initial in-home assessment? Maybe beyond just like the square footage of my house. I'm sure that's probably one of the factors.
Yeah, it's definitely one of the factors. There's a an awful lot that goes into sizing. So it all stems from basically a load calculation, or we call it a manual J. It's a calculation that's done to determine how many heating BTUs or cooling BTUs you need for the space you are trying to condition. And how we end up with getting that ultimate number out of the manual J is by asking questions like insulation values in the exterior walls, insulation values of the attic, what kind of windows does the home have? Is it double pane vinyl? Is it single pane old wood windows? Um, how old is the home? How many fireplaces, infiltration, and stuff like that. So I typically run through a lot of those questions with the homeowner while I'm on site doing my assessment. And even Mass Save, even as Mass Save goes out and they do their energy assessment, they could probably provide us a better understanding of that home's insulation quality. So that's huge, is the insulation values in of the home
What
individual.
if I don't know my, insulation values in my house? Are you able to figure that out? Do you have to cut a hole in the wall in order to check and see what insulation is behind there, or how does that work?
So I have seen, energy audits where the company does cut holes or drills holes in the wall to determine if there's insulation in there or not. Usually, I can kind of get a good sense of what might be in there. If it's a 2x4 wall, exterior wall, and the customer, it's an older home. You're going, but they say they have some insulation in there. It's, your best bet is probably go somewhere like R11. If it's a 2x6 wall, it's going to be a little bit better insulation because it's a thicker wall. They were able to get more in there. So stuff you can kind of you can get a good sense of what it is and almost use like a worst case scenario. Unless, of course, there's absolutely none. You'd want to know that. You'd want to know if there was none.
Probably best to have them just put a little hole in the wall or something like that, and just double check that you have the right insulation in there.
Right, and that's where those energy assessments come in as far as assessing the insulation quality of the house. Helps us do our load calculation. Other than that manual J, with ductless, you can do the whole house. You can do small parts of the house. You can do one room, two room, three room. So that the space you're trying to serve plays a factor in it too. If it's only a 300 square foot room, then obviously you only need the load calculation for that one room you're trying to condition.
Right, as opposed to like replacing your heating and cooling system, and you're doing the entire house. That's a different size system that you're going to need. Yeah.
Exactly. If you have a hot air furnace that does the whole house, you need to know the whole load for the whole house. If you just want to condition the second floor with ductless for the summertime, you just need to know the cooling load for that second floor. So.
Is there a difference in efficiency or performance with oversized systems or undersized systems? So you're with that manual J load calculation that you're talking about, you're trying to properly size the system for my home. But what if you made a mistake and you undersized the system or oversized the system? What are some of the problems maybe that could arise with that?
So with undersizing, you'll probably see during the extreme conditions, super hot or super cold, whatever you're designing for, you may not be able to maintain your desired set point temperature if the unit's not quite big enough. What that would look like on a 98-degree day in the summer, if you're trying to hit 70 degrees in that room and it's a little too small, you might get 72, 74. It would just be running constantly. Running constantly, yep. In the wintertime, on those 15-degree days, 13-degree days, 10-degree days, if it's too small, you might see instead of a 70-degree set point temperature, you might only get 66, 67, 68. So you just won't be able to maintain the desired set point temperature you have, and it will never stop running, basically. But if you go oversized, then you kind of have the opposite problem. That unit's going to satisfy that room too quickly. You might get some short cycling where the unit is on and then immediately off, and then on again and immediately off. So that could also run up your energy bill because you want that modulating condenser outside to run a lot for a long run cycle, but not work too hard. Just kind of like even linear line. Short cycling, that unit is going to come on, shut off, come on, shut off. So that's also not what you want, as well as the typical oversizing problems with air conditioning, cold, clammy rooms where they're getting that temperature cold enough, but they're not getting the humidity out of the space.
Right, because they're not running long enough to get the humidity out of there. They're just, like you said, turning on and turning off so quick that you're getting the temperature where you want it to be, but it's still humid in the room.
Yeah, the temperature is where it needs to be, but that unit has not had the chance to wring out that humidity from the space, so you get a cold, clammy space.
So that's really important then to do those J load calculations. Really make sure that you're installing the right size system for the home. Okay. So what ductless systems, in terms of like multi-zone systems, how do you determine the size of like each individual unit compared to maybe just a single large unit? I guess I'm thinking, how do you determine for a space, like do you need two different units that to cool or heat that space, or one larger unit? Or I guess it's more like a system design question. In terms of we're talking about how to size a ductless system for your home, but then there's multiple different ways to do that, right? You could have two units or you could have one unit, etc.
Right. Yeah, so obviously you size the indoor unit for the space it's going to serve, and the space it's going to serve, you have to really look at, can the air that's coming out of this ductless unit actually physically get to that space you're trying to have it condition? Right? If the answer is yes, if you have a dining room and a living room with a huge opening in between one another, and you're orientating that ductless unit in the right direction to blow through that opening, you can say, yes, I can physically get the air from point A to point B. So those two spaces can be served by one unit, and then therefore the load calc for those two spaces will be wrapped up into the size of that one unit. If you can't get the air physically from one room to another, then I would say you have to break it up. You have to either do two ductless units in one, if you have two bedrooms upstairs and the doors are closed at night, you have to have either two ductless units, one in each bedroom, or you have to do something like a ducted system with vents in each bedroom. But you need to actually be able to get the air from point A to point B to be able to say, yes, this unit's going to serve both these spaces.
Do you always only need, one outdoor unit? I know there's outdoor units, multi-zone units that can have, two or four or eight, indoor units attached to them. Is that always better than having two or three outdoor units with, maybe you had three outdoor units with two indoor units on each one of those, so you'd have six total. Is that, do you sometimes need that versus having an outdoor unit that just one outdoor unit that runs six indoor units? Are there reasons why you might need multiple outdoor units?
Yeah, so there's a lot of reasons why there's a lot of reasons why you might need one, and there's a lot of reasons why you might want multiple. For multiple, I always say, if you have multiple systems, you don't have all your eggs in one basket. You kind of have some redundancy there, especially if it's your only source of heat. Yep. 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 And then the other thing with multiple condensers outside is configuration, how it's actually going to come together. Sometimes it's easier to split up into multiple systems instead of having one large system. If you do that, you sometimes you can end up with not having pipes running all over the outside of your house if you split them up. So that's one reason why we might split. Another reason is if you're splitting, it's nice if you can split level to level, have a condenser for one level and a system for one level and a system for the other. It's good. That's good for load shedding. I mean, in a perfect world, we'd put single zones all over the place, one to one, and you'd have an individual system for every indoor unit. It's just not practical. Um, and then on the flip side, where you might want one larger system for the whole house instead of maybe two separate systems, is, it can also work in reverse. It could also work out cleaner sometimes to have one system. It all depends on the application. You also might have a restriction, capacity restriction in your electric panel, where your electric panel can't support multiple systems. You only really have space and power for one system. We see that a lot, where the customer has no more space in their panel and they have 100 amp service only. We got to stick with one outside condenser. That's just, unless they want to upgrade their service to 200 amps. So there's a lot of factors that come into play when we're on site doing our assessment, whether we would recommend one or multiple. It's really a case by case scenario, but there's so many factors for each.
And then once the system is sized and it's installed, is there any flexibility to change it afterwards? Like, say we did undersize the system, and I realized that, geez, this indoor unit that's cooling my dining room and living room is not really keeping up, with it. We need to, increase that from 6,000 BTUs to 9,000, or 6,000 to 12,000, or something like that. Is there any opportunity to like resize that afterwards and change that without having to replace the entire system?
Yeah, so ideally we'd like to have the right size from the get go, ideally. But if that was to happen, there is possibility you could go from a 6 to a 9 or a 9 to a 12. You could pull that head off the wall, put the larger head on. If it uses the same size refrigerant pipes, you're set and good to go. You also have to figure out, okay, does my condenser outside have the extra capacity needed to power, or to now give that unit the extra capacity it needs. So you might be tapped out on the outside unit. That's really something that we would try to avoid at all costs, but that would be a case by case. I would like to think that most of the time we're utilizing that condenser outside that we put in to the maximum capacity already. So, it might be a pretty good chance where you can't simply swap that out. You might have to go to a larger condenser outside and a larger indoor unit.